Okay, so what we are interested in is the following. Okay, so here is a pulse. Okay, and you've seen a function in calculus. Okay, so let's use the blackboard. So here's a function. Fx. Okay, and let's say I want to shift this function by distance d. How do you do that? The way to do that is, so fx minus d will be the function shifted by distance d. Okay, so that's how you shift a distance. That's how you shift the function by distance d. Okay. Now here's a very neat little thing. Okay. So let's say you have this function, and now let's say you want to make it travel at velocity v. And here is a simple way to make it travel at velocity v. So here is this pulse, fx minus vt will make it travel at velocity v. Okay, so that's the simple little trick that you do. And now what we'll do is, we were interested in sine waves. You saw that. So let's say here is a sine wave. So here's a snapshot of the wave on that string. And now all you have to do is do fx minus vt, the same trick as before. The same trick as before. Fx minus vt will make this wave, the sine wave, travel to the right at velocity v. Okay. So what we have is a mathematical description. Hang on a second. So this is sine, by the way, this is kx, sine kx, and a is the amplitude. Fx is a sine kx. That's what this is. K is 2 pi lambda. So this is a sine 2 pi lambda by times x. Okay. Where lambda is this, there is lambda, this distance. Okay, so this wave, this function is described, this wave is described by that function. Okay. And so if you want to make this sine wave travel to the right, you have fx of t. This function is a sine 2 pi by lambda x minus vt. So there you made a sine wave travel to the right. So what this mathematical function gives you is, it's describing to you this wave. So this traveling wave is given by this function. Okay, so let me clear that, write it even slightly more clearly. Okay. So here's this wave. There's the amplitude. This is x. So and y x t. So here's a snapshot of the wave at a given point. 2 pi by lambda x minus vt. Where lambda is this length. And as t increases, this wave will travel to the right. Okay. And now what we'll do is we will write, okay, so that's this fellow right here describes that function describes this wave traveling to the right. Okay, and all of that was based on just this little trick that you learned in calculus. If you had a function like that, if you had this function to translate that function, to move that function to the right, all you did was replace x by x minus d. And of course, if you want to displace the function by d to the right, it's fx is replaced by fx minus d. And similarly, if you want to shift the function by d to the left, all you do is replace x by x plus d. Wherever you replace x by x plus d, if you replace x by x plus d, then you shift the function to the left. Okay, so keep that in mind as we go through these slides. So here's a function, and if you want to make the pulse travel to the right at a velocity v, all you do is replace x by x minus vt. If you want to make the pulse travel to the left at v, at velocity v, you replace x by x plus vt. Okay. So x minus vt is a pulse traveling to the right, and x plus vt is a pulse traveling to the left. All right, so here's a, so we saw that. Now let me explain this expression. So you saw that the wave traveling to the right is given by a sine 2 pi by lambda x minus vt. Okay, so what you'll see in a minute is v is on the velocity of the wave is the frequency times the wavelength. Oops, frequency times the wavelength, and frequency can be written as 2 pi omega over 2 pi omega over 2 pi, and wavelength is 2 pi over k. If you refer to the definitions of wave number and frequency, omega was equal to 2 pi f, and k was equal to 2 pi lambda. Okay, from these definitions, the wave velocity is given by that. Okay, all right, well, we are going to substitute this up there. Okay, so y xt is a times sine 2 pi over lambda x minus v. V is omega by k. Okay. So omega by k t. Okay. And so this is a sine, this is k, this right here is k, k x minus omega over k t, a sine kx minus omega t. Okay. So there is the sine wave traveling to the right. Okay. This travels to the right, and similarly you can figure out a wave traveling to the left will be given by sine kx plus omega t. This wave travels, here's a sine wave traveling to the left. Okay. So that's what this, oh wow. So I did all of that and I had the wrong screen. All right, anyways, so so here's the, so here's, okay, so this sine wave traveling to the right was given by this expression. you will see in a second that velocity of a wave is given by frequency times the wavelength, and frequency omega was 2 pi times f. So frequency is omega divided by 2 pi. Frequency is omega divided by 2 pi. Wave number was 2 pi by lambda, and lambda is 2 pi by k, 2 pi by k. All right, so velocity of a wave is frequency times wavelength, and it's also equal to omega by k. Okay, so we are going to simplify this. We're going to write this in conventional form, this expression. Okay, so this traveling wave to the right is a sine 2 pi by lambda x minus vt. V is replaced by omega by k. And this right here is also k. So y xt is a sine k x minus omega by kt. That's kx, and this k cancels, and so the second term is minus omega t. So y xt is a sine kx minus omega t. So here's a wave traveling to the right is given by that, and similarly a wave traveling to the left will be given by that expression. Okay. And that's what you're seeing here. So here's a sine wave traveling to the right. Okay. So what we have achieved is this complicated looking thing. We have learned to express this in mathematical form. And that is given by this expression. Okay, so that's what we've learned. Okay, so this is the wave traveling to the right. A is the amplitude of the wave, K is the wave number, and omega is the angular frequency. This quantity within the parentheses is called the phase of the wave. Okay, so those are the technical terms. Okay. So for instance, here's a snapshot of the wave at t equal to 0, for instance, the green wave. And so the point A is sine pi by 2, corresponds to sine. An angle of pi by 2, so sine pi by 2 would be 1, and the wave a sine kx minus omega t would be given. So let me go back. So this guy is the phase, okay, and at that point A, we saw that this would have to be pi by 2, giving you sine pi by 2 1, and the y coordinate of that wave would be a. So so the phase of that wave would be pi by, at that point would be pi by 2. That would be pi by 2. So this is the phase of the wave. The phase is pi by 2 for that point, and we are interested in how fast does that phase travel. So you put that equal to pi by 2, take the time derivative of that. K and omega are time constants in time. It's only the x coordinate at that point that changes. Dx by dt is the velocity of the wave. And so the velocity of the wave is omega by k from this expression, equal to f times lambda. Okay. So this is called the phase velocity, and the phase velocity, or in our case, this is the velocity of the wave, is omega by k, and it's equal to frequency times the wavelength. Okay. So here's a wave traveling to the left. Okay. Remember, x minus omega t is a wave traveling to the right. Kx minus omega t is a wave traveling to the right, and this wave is traveling to the left. All right, I'm going to pause now and let you guys ask questions.